All right, guys, in this video, we're going to be looking at some Beer's Law questions. There are a couple short answer questions. In this first one, a student performs a spectrophotometry experiment using solutions of nickel perchlorate. The student needs to make a standard curve and determine the concentration of nickel perchlorate in a sample with an unknown concentration. So this is a spectrophotometry absorbance graph, where it relates the absorbance to the wavelength. Based on the absorbance spectrum of the nickel perchlorate shown in the preceding graph, what wavelength should the student use in the experiment to achieve the greatest precision? Okay, when we're looking for what to determine a wavelength of a particular compound like nickel perchlorate, we're going to be looking for where is the absorbance peak the highest in that graph. So that would be right here. So this is the peak we're looking for. I know there's something over here that looks like stuff. Really, they're going to make it very obvious on the test, and we're going to be going for the biggest peak, so we'll be looking at this one. And when we're looking for the wavelength, we're looking for it right here. So if this is the peak part, we want the wavelength right here. Okay, on the AP test, they usually give you a range, so make sure you're just within that range. And in this particular question, you don't have to explain it. You just got to put the number down that's correct. Well, it looks like there's 1, 2, 3, 4, 5 spots, so it's every 20, so that's 420. 440, 460, 480. So this right here would be 380. So I imagine if you do something between 380, 400, I'm just going to split the difference and say 390 nanometers. Okay, they give you a range, so you should just be fine, and that would be all you have to put right there. Okay. On this, we got another absorbance graph. This time, though, it's absorbance versus concentration, not absorbance versus wavelength. The standard curve generated by the student is provided above. The student measures an absorbance of 0.3 for an unknown solution. Using the standard curve provided, determine the molarity of the nickel perchlorate in the unknown solution. So this student went ahead, they took the unknown sample, they put it in through their spectrophotometry, and they got an absorbance of 0.3. So these graphs are really nice. All you got to find is where's that intersecting line. So 0.3 ends like right here. So the molarity would be this one right here. And we want to be as accurate as we can, and it is obviously going to be in molarity. So it looks like every line we go, let's see, this would be 0.06. This is 0.08 from here to here. Is that every 5.065, 0.07, 75, yeah. So this would be about approximately, my guess is 0.065 molarity. Once again, as long as you're within that range, you should be fine, and you'll be okay. So just make sure you're as close as possible. We're trying to read it. It does look like it's right over there here, so maybe it's 0.066, 0.067, but they're going to give you leeway as long as you're within that range. Okay, don't forget molarity, since we are looking for the molarity of nickel perchlorate, and we're just looking for the molarity, so make sure to keep those units in there. They often give you 1 point for the correct and one number and 1 point for the correct units, so don't forget your units. All right, last one, we have another absorbance versus concentration graph, just like the one above. A second student repeats the procedure using the same spectrophotometer, but makes an error, which results in a dashed line in the graph above. Assuming the first student's data shown above and the solid line are correct, identify one error that could account for the second student's standard curve being less steep than they obtained from the first student. So we'll notice that this solid line is the good line, and this dashed line is wrong. There was an error. We're trying to figure out what was a possible error that made it result in this. Well, ultimately what I'm seeing here is that the concentrations are too low based on the correct absorbance peak, right? If we're supposed to have an absorbance peak of 0.3, it should end up here. Instead, we're ending up over here with a higher concentration. So, we are ending up with a higher concentration for the absorbances than we should. So if we have a higher concentration than we should, that means that we have too much nickel chlorate in our sample compared to the original solid line. So when we talk about our error, we need to talk about how the concentration is too high, so the molarity is too high, and a possible error is there's too much nickel chlorate in that sample, as opposed to the solid line. So there's actually too much of the solute. Too much solute was added compared to the solvent in that ratio. So that could be a possible error. When they produced their sample, they put in too much nickel perchlorate. That resulted in a higher concentration than that is supposed to happen. Okay,